Part 4 here, we got a few more types of chemical reactions. We left off looking at single replacement reaction, how it's going to be a single element plus a compound, and the single elements are going to switch. So whoever's with the compound. Now, the problem with that is that doesn't always happen. In other words, in order for the switch to take place, the one element has to be more reactive than the other. Now, how are you going to know that? In order to be able to predict whether it's going to happen, what you end up using is this activity series of metals, which you can find on the PowerPoint, you can find in your book. Basically, it's saying if the single element that you're trying to switch out is higher on this chart, it's more reactive, the reaction will happen and it'll do like we're saying. If it's lower, like if iron's trying to switch out and replace lithium, a compound that lithium's in, it's not going to happen because it's not as reactive. So therefore, it's not the reaction. We would just say no reaction. It doesn't happen. So not just because you put two elements together doesn't always mean they're going to react and do something. A lot of times they don't because the one is not as reactive as the other. So that's one of the things in predicting, which I said we're not going to do a lot with predicting. I just want to let you know that they don't always happen. And that was the activity series of metals. There is an activity series of nonmetals that go for the halogens, but honestly, this is the same way they are in the chart. So I just look up at the periodic chart, and it's fluorine's higher than chlorine, then bromine, and then iodine. I just look at they're all right in a chart, right in line. Which one's higher will tell you whether it will actually. So here, chlorine, bromine wants to switch out with chlorine. Well, bromine by itself is not higher than chlorine, so it'll just be a no reaction at the end. The fourth type is a double replacement. And this one, you're not going to have you're going to have two compounds. Like this one here is sodium hydroxide, a compound, plus iron 3 chloride, which is another compound. So you have a compound plus a compound, and they're going to switch partners. Not just a single one, both of them are going to switch. So you would end up getting the iron to go with the hydroxide, and the sodium's going to go with the chlorine. So they're both going to switch partners in this case. And that's a double replacement reaction. Most of the time, these are going to occur in water or aqueous solutions. So that's why you'll see the AQs, and we'll get into solubility rules to tell you, again, if this is actually going to be a reaction that happens or not. Because if they both dissolve in water, nothing happens. So you don't get a reaction. But being able to identify them, it should be pretty easy because it's compound plus a compound. So if we look at a summary, always look at the reactants. An element plus an element, it's got to be a combination reaction. Just starting with one thing that's a compound, it's always a decomposition. Element plus a compound, it's got to be single, and compound plus compound's a double. There is a fifth type of reaction called a combustion reaction, and combustion means oxygen. And this is very specific. It only occurs when oxygen is a reactant. So it's got to be on the left side, and your products will always be carbon dioxide and water. Now, one slight change to that, if it's an incomplete combustion, it can be carbon monoxide in water instead of carbon dioxide. But you're still going to have the carbon and the oxygen, you're going to have water. So it's very close. The one we're not going to do, it's not even in your book, is acid-base reaction. An acid plus a base, we always say neutralize. What do you neutralize an acid with? You put a base with it. The reason is because when that reaction takes place, an acid plus a base will give you a salt plus water. And water is not hard. So that's why it neutralizes it. It ends up making water. So quick summary, being able to look at your reactions, skeleton equations to balanced equations to be able to tell what type of reaction there is. So that's it for this one. We tried to scale it down, make it a little easier for you. So if there's any questions, make sure you email me. Look at the full PowerPoint because I scaled this down a lot. Look at your book. Look at the videos that we included. And if you have any questions, just feel free to email. And we'll see you next week.